Hello, my name is Ashley Freeman, and I am currently a PhD candidate at the Norwegian University of Science and Technology. Today, on behalf of myself and my co-authors, Dr. Wan and Dr. Bertolin, I will discuss a study we are performing here in the engineering department that focuses on the effect which indentation spacing has on the mechanical characterization of proteinaceous films when using nano-indentation. First, I will start by giving a brief introduction on our motivation to study these types of materials. Then I will explain how our materials were prepared, after which I will discuss our methodology, which investigates the spacing between sequential indents or adjacent indents. Following this, I will then go on to show you some of our results. And lastly, I will conclude this presentation by summarizing the main findings from our study. Gelatin is a biopolymer which has found many applications in numerous industries ranging from pharmaceutical to conservation and artist materials. Although its exact emergence is unknown, the use of gelatin-based adhesives or animal glues is often dated back to ancient Egypt. Since then, the use of animal glues as the binding media of paints or even as an adhesive to re-adhere paint to its support has become common practice. However, historic paints or consolidants composed of these types of biopolymers can deteriorate with time. Consequently, understanding their mechanical behavior and properties is essential for ensuring the safety and integrity of artworks containing these proteinaceous materials. Gelatin is a combination of peptides and proteins derived by partial hydrolysis of collagen extracted from the skin, bones, and connective tissues of animals. Depending on the source of the collagen, be it from a cow, pig, rabbit, or fish, the structure, composition, and properties will vary. Typically, after hydrolysis, the extracted material is eventually dried. Here, we prepared our films, as you can see in this lower image, actually using a wet process, or casting, in which we prepared solutions of gelatin by combining our commercial gelatin with water and then heating it as instructed by the manufacturer. After we casted our materials, they were allowed to dry for at least 275 days. For our research, we focused on 4 gelatin-based adhesive films which were prepared from commercial products. In particular, we focused on bone glue and hide glue, which were both from cows, rabbit skin glue, and sturgeon glue. 10 by 10 centimeter rectangular specimen were prepared from the middle of the films and adhered to a metal substrate, as shown in this lower image. However, as the specimen are transparent and difficult to capture in an image, a red rectangle is used to highlight these transparent films. These samples were then subjected to indentation tests. Here, we use the Oliver and Farr method, allowing us to evaluate reduced modulus and indentation hardness. Although for the purpose of this presentation, we will only be showing the modulus values which were obtained. As mentioned at the beginning of this presentation, we are interested in examining the effect that spacing has on these obtained parameters. When consulting the ISO standard for indentation of metallic materials, it suggests a minimum distance of at least 10 times the indentation diameter for materials other than ceramics or metals, such as the adhesive films presented here. However, shorter distances can be used if experimental data obtained at these closer distances are comparable to those obtained at the recommended separation. To examine the effect that spacing has on these obtained parameters, we performed indents with linear loading up to a maximum load of 10 millinewtons, followed by a short pause segment, and then linear unloading. The indents were carried out with varying spacing in 2 different orientations, as imaged here. The first orientation was to perform indentation tests with equal spacing in the X and Y directions, or as rows and columns, with spacing ranging from 3 microns to 35 microns. Whereas a 3 by 3 array was used as the second type of testing orientation. For the array, we used spacing that ranged from 6 to 35 microns. Here, box and whisker plots were constructed using indentation test as specific separation, regardless of the testing orientation, thus resulting in 5 groups per test specimen, as shown at the bottom of each plot, being 3, 6, 9, 14, and 35 microns. However, complications were encountered during testing and not all indents were completed during the study. The number of tests which were completed are denoted in each plot, in which n is the number of tests used for analysis. These n values can be found at the top of each plot. When examining the spacing at which the median values or the middle line within the box and whisker plots begin to stabilize, all 4 adhesives start to stabilize between a spacing of 9 and 14 microns. However, this stabilization is most evident when examining the results for fish. If we were to take a closer look at this plot, and specifically focusing on the median values begin to stabilize at a spacing greater than 9 microns, which means that the modulus value of indents, which are at least 9 microns apart from one another, are comparable. And if we were to look at a typical load displacement curve recorded by the indentation system, as shown here in the upper right-hand image, which for our tests were performed to a maximum load of 10 millinewtons, we would see that generally these tests resulted in max depths about 1 micron. And if we were to compare these depths with the separation at which our results begin to stabilize, we would notice that the spacing between indents that were greater than 10 times the indentation depth resulted in comparable modulus values. As the data obtained between a spacing of 9 and 35 microns are considered to be comparable, the data at these spacings were combined. This allowed for a more direct comparison between the general response of the 4 different adhesives. Here, the median modulus values ranged from 6.7 to 9 gigapascals, with hide glue displaying the highest median value of 9 gigapascal, while bone glue exhibited the lowest median value of 6.7 gigapascal. Whereas the rabbit skin glue and fish adhesive films displayed moduli which fell between the hide glue and bone glue. Conventionally, mechanical properties of these materials are characterized by means of macroscopic tensile testing, although the modulus values reported here were actually obtained using nanoindentation. Nevertheless, the trends presented here were in agreement with those presented by authors who used tensile testing. In conclusion, we found that an indentation spacing, which is greater than 10 times the indentation depth, is appropriate for these types of materials. Our findings correspond with other research groups who have performed indentation spacing studies on different types of materials such as fused silica, polycarbonate, and polystyrene. Lastly, when combining results at distances which exhibited little to no effect, hide glue displayed the highest median values, where bone glue exhibited the lowest. And finally, I would like to thank you for your time and your attention.